Hey, what's up, YouTube? This problem is from the qualifying exam for the MIT Integration B. I believe it was the 2013 qualifying exam. Let's try to work it out. Solution. So I'm not sure if there's a clever trick to do this integral. If you know of a clever way, leave a comment below. I'm thinking we just break it up. So here we have x minus 3. Here we have x minus 3. So it'd be nice if we just let u be x minus 3, except here it's just x. So I'm thinking we break it up like this, 0 to 6, x dx, plus, and then just deal with the other piece, 0 to 6, parentheses, and then x minus 3 to the 7, plus sine of x minus 3, and then parentheses dx. And then for the second integral, we can just make a basic u sub. We'll just let u be equal to x minus 3. And then in that case, du is simply dx. Now, because we made a u sub and we have limits of integration, we're supposed to change them, right? Because these are x values here, so they have to become u values. So like when x is 0, u, well, you plug in the 0 here, right? So it's 0 minus 3, so negative 3. And then we have to do the 6 also. So when x is 6, u is 6 minus 3, so that's 3. Okay, so this is going to become a 3, and this is going to become a negative 3. Integrating the first integral, it's pretty easy. We just use the power rule, right? It's x squared over 2. There's a 1, and you add 1 and divide by the result. And we're going from 0 to 6. And then plus, this is negative 3 to 3. Then we have u to the 7 plus, oh, I see a trick. I just realized something. This is what you call beautiful, right? And then we have that. We probably could have done this trick at the beginning. It might have worked without breaking it up. I don't know. I'd have to think about it. But this right here, my friends, is an odd function. If you let f of u be equal to u to the 7 plus sine u, it's odd. And why does that matter? Because whenever you have, let me write it up here, if you have f odd and you integrate it from negative a to a, f of x dx, you get 0, okay? That's always equal to 0 if you have an odd function on this is called a symmetric interval. Whenever it's like this, negative a to a, it's a symmetric interval. So here, a is 3, right, because it's negative 3 to 3. So what does odd mean? Odd means if you plug in negative x, you get back negative f of x. And that's certainly the case here. Let me use a different color here. Let me show you. If you do f of negative u, you get negative u to the 7 plus sine of negative u. That's pretty cool. I did not know this would happen. And then 7 is odd, so you can pull the negative out, like that. And then sine is also odd. It's an odd function, so you can also pull the negative out, like that. Then you can pull out a negative 1 like this, and you get u to the 7 plus sine u. Right, but this piece here, that's what you started with, right? So that's negative 1 times f of u. Boom, and that's the proof. We just proved that this bad boy is odd. So you have an odd function over a symmetric interval, so this whole thing here is 0. So let's finish this. Really, really cool. So here in this one, you plug in the 6 first. So you get 6 squared over 2. Minus, and then you plug in 0. So you get 0 squared over 2. Plus 0. All right, so that's really, really cool. So we get 36 over 2, which is 18. So the answer to this problem is 18. So 18. Really cool problem. I did not think this would happen. This is from the MIT qualifying exam for the Integration B that they had back in 2013. I guess it wouldn't work if we didn't separate it, right? Because the answer is 18. So if I'm saying that it would work, then the whole thing would be 0, which is false because we know it's 18. So you break it up, and then you use the fact that this is an odd function, right? And it's not obvious at first because it's 0 to 6. I usually use this as the key, like negative a to a. If I see that in a problem, I think about this, right? But in this case, I didn't see that. I just saw the 0 to 6, and so I just took it one step at a time. Then when we got here, I said, hey, wait a minute. negative a to a. Oh yeah, it's and this ends up being odd and it works out. So I hope that was helpful.